Yes, sir. Yes, sir. We can go further, sir. I'll text them to join.
Okay, very good. Thanks a lot. Extremely sorry for the inconvenience. We lost quite a bit of time today on this. Hopefully, we'll make it smoother tomorrow. Okay, so I was mentioning about the industrial IoT disrupting to get to the autonomous operations. You can visualize that how that brings the real world of to a digital twin for operating the various different parameters, whether it is for an asset, equipment, or for a process, or for even an industrial unit. How do you bring the operational excellence? There is significant value of IoT applied on the industries. Of course, now with the interest of time, I will keep skipping some of the slides to go to specific aspects. I did mention about it's disrupting the organizations. The complexities are much higher, which means that the approach is pretty different for applying for the IoT in industries, primarily because here we are talking about the life of the people. Because when imagine in a big plant, in an underground mining or oil and gas plant or refinery plant, if we are able to somebody is taking a control on just hacking the set point for a speed of a motor, it's going to obviously damage a lot of the assets as well as the people's lives. So it's very important when we look at the IoT in the context of how it will be applied meaningfully with the industrial cybersecurity, industrial data integrity, and industrial application of AI by also bringing the domain expertise together. That's exactly is what is making us what is an IoT into an industrial IoT. So the industrial input you see here, it's bringing the industrial processes, industrial reference architectures, industrial standards, and industrial deployment practices, industrial cybersecurity standards, all that is brought in for defining the IoT applicable for industries. It's also very important to know that the kind of data sources are very different in industry than a typical social IoT or the B2C commercial IoTs as well. Just for a second, imagine that what I mentioned as the autonomous, some we might think that, sorry, is it real? And is it really that the plants are becoming autonomous? Answer is yes, they are towards autonomous, which means that everything in the plant is connected. Even 10 years back, when we go to industry, you will see that there are set of field devices. You have the pumps, motors, valves, transmitters, pressure transmitters, temperature sensors. They will be measuring different parameters. They all will be brought to certain controllers, PLCs, right? Controllers, where you will control program logic to control the IOs. Then you have control stations, wherein you have distributed control systems, where you will be able to using the control loops. You will modify your PNID loops, and you will whatever you studied on your control systems, you will apply to make it how to make a stable functioning of a specific process. Then people will plan on top of that, saying, how do I do my production scheduling? How do I ensure my quality of my pipeline is what I'm producing is right? How do I ensure my spare parts management is helping me for achieving the operational efficiency and so on? This was a very hierarchical in earlier in terms of each levels. But with the disruption of IoT, as you can see in the right side, it become completely a smart factory, which means that any component is intelligent and they can disseminate information to anywhere. While there's a lot of advantage to that, it is also extremely important that it needs to be controlled. Otherwise, as I mentioned, internally or externally, somebody could directly go and influence a specific product or equipment that could potentially damage the entire operations. So obviously, the four key elements is the component by itself should become intelligent IoT. So there's a lot of technologies for how do you make a device IoT enabled or a smart device. The second thing is how do we get the data from different technologies you would have studied about. Okay, so I use the MQTT protocol. I can use AMQP protocol. I could use potentially a standard, a Profibus standards to bring it to an edge. There are different ways you bring the data to be usable. And next thing is the data has to be contextualized. We can't just take the raw data. If I just see that, okay, the temperature goes from 10 to 20, what does it really mean? Do I need to act? How do I apply that for me to improve the performance of my operations? That needs always a contextualizing the data with the different systems. And more importantly, data by itself, we know that it's not much value. In fact, in the industry context, I often being asked by the customers, very large organizations that, oh, am I actually spending more money on storing the data versus the value of the data? So it's very important that whatever the IoT is bringing the data, we should apply the analytics and AI to bring predictions, to bring the prescriptive analytics, to bring optimizations, to bring the value of the digital. So and we saw that I'm going to skip some of them because we lost almost 30 minutes as well, right? So the difference that we see from the general purpose IoT to the industrial IoT is the four major phenomena of digitalization. First thing is that it starts from what is the purpose. It's not about creating an IoT device and system and implementing a project. The good part is that in industries, it is categorized as it has to be one of those five. It needs to be an operational performance or asset performance, safety and sustainability, supply chain optimization, or overall the operational excellence. That becomes the five different business outcomes broadly. So you look at what is the specific purpose for which we want to look at the industrial IoT systems. The second thing is that, as I mentioned, we need to always look at with the context of the data, because you have, when you enter into the industry, you will have many of the equipments will have the sensors today, smart sensors, IoT sensors, but that's not the only source of data. A lot of data is captured by the people mind in systems, IT systems such as SAP. It could be even your Microsoft Office applications. It could be also the engineering systems, design systems where you design the plant. All that information needs to be brought together, and that needs to be integrated in a meaningful way, real time, along with the sensor data. And we need to intelligently map it. And imagine that for 800,000 sensors that you have it in the plant, for more than 10,000 equipments, you can't be doing this mapping manually. It needs to be automated. So even you apply the artificial intelligence, but also map it in terms of this particular sensor data needs to be mapped to this IoT data needs to be mapped to this particular system information coming from an IT system, as an example, right? IT system could be your energy management system, or it could be SAP system or Oracle ERP system, and so on as well. Third aspect is the domain expertise. So what's very important, because we need to look at using the data for specific industrial domain aspects. Example, predictive maintenance is a very common application of IoT. Right? If I need to look at how do I identify the faults, the fault that can happen on an equipment, say in 2 weeks advance, I can have tons of sensors put across. In fact, many times we don't even put sensors. We can use something called visual sensors. We get the data from the control systems which are connecting to this. You can look at the RMS value of the motor. You can look at potentially that how many times the trips have happened. Based on all different data, you could analyze that what is the potential failure of a critical equipment such as turbine or generator or motor or compressor. How that we will be able to find out. That's an example of using the domain expertise. It's the same thing for many different things. Like as an example, we have a drone-based detection of the gas leakage. City such as Pondicherry or cities such as the Chennai, we want to look at across the gas pipelines. We want to look at the leakage detection using the movable sensor mechanisms that can detect. You can't be putting sensor across the pipeline, but the pipeline contains underneath the gas. And imagine that you have an analyzer that is on the drone that is keep on checking the pipeline. It can extract the level of methane value and alarm it back to the cloud that being seen from remotely, which I was showing in our collaborative operation centers, that there is potential leakage here because the composition of the gas is different than what is the permissible value. So you use the industry domain knowledge and data models, combine that with the sensor data coming from there and the analyzer, and resolve the real life problems. Of course, most important is that people want to see the value and the return on investments. It is not in the industries. These projects are not done for just for as a hobby, right? They are done for making a significant difference on the profitability, and that means that we need to have software solutions that are deploying IoT that can bring quick returns on investment. So what does it really change? And I'm sure that many of us would have studied in our electrical engineering or even in the computer science or even mechanical engineering. You would have seen that typically a control loop is all about this, right? You will sense it, you will analyze, and you will act. That's what typically done by the PLCs, control systems, and so on. But what's happening when we go to the industrial IoT and industrial AI world is there is an outer look. It's not about just only that if there is a change in set point, you go and fix it, but you will also understand by means of looking at the data what potentially can go wrong, what has gone wrong, and try to apply the algorithms and solve it. So you perceive what's going wrong, not just only exactly see the sensing, but you from there you derive what is going wrong or what is changing and apply the domain and the AI knowledge and solve it. So that's fundamentally is what making it as you could replace the human or you can augment the human's knowledge within autonomous capabilities of the IoT and AI. Now, industries are investing heavily on moving towards the autonomous plants. And the fundamental driver is the IoT. And we will see in a second that what are the key capabilities of industrial IoT versus the IoT. But the industries are moving from no autonomy, which were there, to go from just helping the operators with certain intelligent systems of knowledge. Now going towards that for majority of the conditions, the operator is just seen as a supervisor. He or she is not really working. The system by itself is autonomous using the IoT and the AI. And we see that a lot happening across, including in India. There are, you possibly would have seen in the news that Tata Steel, as an example, has a full-fledged digitalization plan in Jamshedpur, which can predict the quality of the steel produced just in 20% of the operations. So you could stop it. Instead of wasting for the entire time, you could stop it in the middle that, oh, it's going to go wrong. That's using the IoT and the AI technologies. Right? So what that means, first thing is that for us, it's all about how do I unlock the data which is not being used. Imagine that so much of data coming from the IoT sensors are absolutely not being used in the industry and the different IT systems data we are currently not able to see, not able to use it because they are not collected, they are not contextualized. But if we use it, there could be a significant productivity gain by in the degree of 40%. That means that if a fully digitalized plant using the IoT could produce 40% cheaper goods than the competition. So imagine that you could either pass on the benefit to the customer or you could make that as your profit in the industry, right? And most complexity is how do you bring the data integration challenge, which I mentioned. You have a real-time data coming from the sensors, and sensors also tend to fail. So you need to have a way of ensuring that how you get the health of the sensor as well along with the data. But then you need to also apply with the different systems data as well. So the IoT turning into the IIoT by means of really 5 major elements. That also defines pretty much how we drive the industrial processes towards implementation of the IoT. Right? Number one, the data landscape is different. Here we are talking about operational data, IT data coming from the data centers, the engineering data that is coming from the design systems. Because you want to depict an equipment or plant in a digital way, you want to make it represented as a digital twin. You need to have the data that's combining from, for instance, how a specific equipment is currently operating. That will come from the operation data. How well it is being maintained is coming from the IT data or the SAP kind of a systems. What is the safety and integrity limits, design limits are coming from the engineering data. You have to look at data together when you go from the IoT to industrial IoT. The second thing is I spoke about the domain expertise, domain process knowledge that needs to be applied. Third, of course, is that it needs a highly scalable, performant, multi-tenant, we call the IoT. Typically, in an industrial landscape, we will generate close to about 9 petabytes of IoT data every day. It's a huge amount of data that needs to be processed. It needs to be also brought value. We can't keep storing because there's a significant cost of storing as well, right? And of course, as I said, AI is a critical element for applying to the data and getting the outcomes. Cybersecurity is paramount. The cybersecurity in the industrial cybersecurity, if you have possibly studied in your curriculum, the industrial cybersecurity is a completely different dimension than a typical IT security. The industrial cybersecurity brings a huge amount of complexities because you are now looking at the systems which were working separately in a plant. Now it's getting connected to the cloud. You are exposing a lot of systems which potentially were isolated network are now getting connected. So those 5 becomes the major aspects to address in the industrial IoT. And the value needs to be also brought at all different ways, right? We should be able to bring the value of IoT by just directly connecting the sensors and devices. And then you can visualize the data, what's the data, and analyze and predict. The other thing is that you engineer them to a control system. You only selectively send the data and solve the problem, such as energy management. Today, if you want to bring value to the sustainability and energy savings, we need to manage the energy of how much we are consuming in the plant and adjust the performance of different equipments and processes. It could be also many times you would have learned the concept about edge, because you can't have so much of data coming directly because there could be a lot of latency and the bandwidth usage. On the other hand, we can make a control system directly sending. Then the challenge is that control system is the heart of the plant, which is operating all these devices. By any means that we are actually creating a cybersecurity challenge, then it could pretty much shut down the plant. You would have possibly learned about the big damages happened in the BP gas plant a couple of years back, primarily because they did open up one specific channel to directly go to the control system for a few seconds and it just damaged. So there's a concept of edge, which is that it separates the world of digital world from the automation world. The edge is sitting very closer to the control systems, which operates the plant, versus what it goes from here is how do you manage effectively using analytics and condition monitoring and so on. So the edge becomes, as you can call, as the architectural control point of the IoT in the industrial context. And as I mentioned, edge is going to give you only the operational data. but we need to get data from the IT systems and engineering system. That's what is coming here to connect. What you see, some of the names are a specific product suites in ABB. You can ignore it for a second, but I'm just using it for illustration. But I will go ahead on three more aspects and take a pause for any questions or possibly fine tuning certain thoughts along the lines. Because this topic today is about industrial processes, I also wanted to focus on how we apply IoT in the industry. What you see here is called as the industry value pillars. Some of these names will be very new for you, don't worry, but you can relate it to things that you are familiar. For instance, how do I do a predictive maintenance for a complete plant from a typical plant maintenance? That is a value driver of a value pillar called asset performance and integrity. As I mentioned earlier, there are five major IoT and digital outcomes for the industries, which are called as the value pillars. So this is where the marriage of industrial domain expertise and the IT technology and the software and AI comes together, because you are looking at solving each of these specific problems, which are called as the value drivers, by means of predicting, optimizing, and bringing the value. You make a significant improvement on operational performance or asset performance, or bring significant value on the safety, or combination of IoT and blockchain, we bring significant improvement on the supply chain management, directly then impacting the company's growth and margin and the workforce performance, and make the workers connected workers so that they have the information any point of time. And you are able to produce what is needed for the customers. You are able to change your production plans very quickly. All that becomes dynamic with the digitalization and IoT. So what that translates into somebody for us, like software engineers and the system engineers who would like to build applications. Each one of them then translate into specific applications, value applications on IoT. One is an IoT platform, other one is an IoT enabled applications with IoT and AI. These things you see are some of the applications very much relevant and highly used on the industries. As an example, dynamic risk analyzer. It always calculates what is the risk of specific parameter of an equipment goes wrong in a process. System anomaly keeps on, like a watchdog, keeps on detecting that what potentially is a deviation that you are seeing from the IoT sensor data or the signals generated, and looking at what predict on what possibly can go wrong. That's all some of the examples, right? You see as a different industry processes. But now when we take this IoT to a plant, and we are looking at mapping the value of IoT to the process of the plant. So it will be different for different process. And we'll see this and we'll go quickly into the technology aspect a bit more as well, right? So if you take a mining or a cement plant, you will go from how do you plan your production to ultimately how do you have the byproduct utilities as well being managed. When companies such as ABB go and work with these plants, we will look at how do we take our software and IoT systems, which are provided either on the cloud or provided on the customer's data centers. We look at mapping their current industry processes and identify where and all it makes sense to focus and sensorize, IoT enable, and change the current networking to make it smart enough to bring the value of data from a process or a specific equipment or a complete plant or even complete enterprise ecosystem. That's what we call as the value map of the industrial IoT. And we also look at customers, okay, so where they are they able to have the visibility of the data? Many of the customers today, industries, they are able to see what is actually happening, but they are not really knowing to go into the self-optimization or autonomous. There are industries today, close to about 25% of the industries are moved already to predictability as well as going towards adaptability. So the value engineering is an industrial process, key process, and you must have studied in your industrial engineering that how do you calculate a value of a process. The TQM techniques that is used for the software quality as an example, or the production quality. We use the industry value engineering as a key process to identify where we should be investing on the IoT and where it will make a significant value on the bottom line of the profitability of the organization. Right. Now let's jump on our bit of an interesting area on the technology side as well. And you've seen that some of the learnings that you do theoretically as well are coming into picture now. Right. If you see an IoT landscape in the customer place, it'll look like this. You will see a whole lot of equipments that are there. Equipment means that machines, robotics. You will have the valves, pumps, motors, compressors, whatnot. You will decide on the pipelines, columns, everything. Not everything is only the rotating, right? You have electrical equipment and so on. Just on top of that, you will have things to control because they are not mechanical, right? You control it using the software. So you will have things like programmable logic controllers or IP controllers, which actually have the closed loop for your control system. You will have a set of control products that will directly control this equipment in an engineered fashion, right? That means that it's not individual equipments. It need to solve a specific process. And as I mentioned, you will always have an edge or set of edges that will separate what is sitting on the automation side to the digital side. The edge will do the data collection and it will manage the data. Then it securely will send the data to the IoT protocols. Typically, the secure IoT protocols are based on the MQTT. And if you need to stream a large amount of data, you use the MQP, right, as the two major protocols. The data using a lot of edge security, it will be pushed to the cloud. And sometimes customers say they don't want to send it to the cloud. They might want to send it to their own data centers, right, which may be in the corporate offices. Once you have the cloud data collected here, then you will look at applying for different use cases. The first use case is that looking at just going above is set of use cases wherein you will manage the best way the different equipments and assets in a fleet way. You can say that all kind of compressors, all kind of the analyzers and so on. That helps on both improving operations and maintenance. The only reason industrial IoT is used is to make things smarter in operations as well as smarter assets. That's pretty much right. Everything boils into these two major categories. These solutions can be these software solutions are provided to customers of different industries, either as a total end-to-end solution or it is also provided as a service, meaning that we tell customer, you don't need to install the software. We will have it from our side on the cloud. We will provide you by taking your data securely, and we will have the agreement with you that we protect your data. We don't share your data. But we will provide you the insights on which are all the aspects that you can improve. So the cybersecurity is applied across the value chain. And that's how the whole industrial IoT landscape works, that you separate your industrial control automation landscape using the edge, then bring the data to the customer's cloud. Cloud, as you all know, that nothing but a data center which is virtual, right? You have a whole big rack of industrial equipment, IT equipments, whether it's a networking, storage, security, all that is made available for compute, as well as the analyze and transform the data into the outcomes. So we use that to provide either as a software that is given to customers, that will be an end-to-end, customer deploys it specifically for them, or we get the data from the different industries and we analyze using our domain expertise and bring the improvement areas for the customers. So as I mentioned, the value engineering is all about how do I look at for the cost I'm paying, what is the performance. This is an extremely important element of the industrial IoT, where we look at the value of the IoT using the value engineering. The second complexity comes is that don't worry about the complexity that you will see in a second. Uh, when we get the data from the different systems, all kind of systems, the data is in a different format. The frequency of the data is also a different format. And you will also see the different kind of hierarchy, a simple bearing in a machine. We need to be able to map it for a complete industry of a big refinery such as Reliance Refinery. You have multiple different layers of the data. And IoT is no meaning unless we are able to get that IoT data mapped to the specific layers, which is called as ISA 95 for the oil and gas industries. PPDM for the upstream industries, CIM is a standard for the utility industries and so on. So you create the master data using what we call as the system digital twin. That makes it then a set of cleaned data for the data scientist and AI modelers to be able to use. How do you do the prediction and how do you do the optimization? I'm going to skip some of this to go faster to cover the ideas. Now, can ask, okay, so what is it's really changing it with an IoT? Because imagine that earlier we were only looking at somebody needs to go and look at if a specific compressor or a specific process of manufacturing medicine, they need to physically go and look at the process. Now with an IoT, we are fully connected of every points that possibly can go wrong, every measurement that we need to bring it in. And you can go completely from just looking at the condition of a specific process of asset. Using the IoT and AI, you can go to predictive maintenance by predictive analytics. You can look at how do I calculate the remaining useful life of a critical equipment. How do I do my complete investment planning for keeping my plant running, right? You can go from one end to the other end using the industrial IoT deployed. This is an example product of the Genix APM. I'm proud of this is being built by the team here in India by an organization which is global, but this one is built completely from here, where you see that we can look at the conditions of the different equipments. We can define the alarms that are coming and predict the failures based on the data, to the extent of going and saying that, okay, I don't want to anymore maintain this equipment. I would like to replace it with a new equipment. These are all very major decisions. You are talking about an investment of $100 million to be made. Those decisions are now no more gut feels. They're all driven by the data coming from the IoT as well as the different systems integrated. Right? I mentioned about the standards are the key thing. If you would like to choose your career to go into the industrial IoT, it is very important that not only the technology, but also look at the standards, industrial standards. So the standards for the safety, standards for the operational excellence, standards for looking at the risk. There are different standards that you apply it when you analyze the data that is coming from the IoT. The key capabilities, many times I'm asked about how do I excel myself on an industrial IoT. And the industrial IoT is defined by 8 major characteristics. Forget about this individual terms. These are the product names that have been put, each of the components. You look at the ones in the red. Analytics becomes the key. Many times we think, oh, is IoT and analytics different or same? The purpose of industrial IoT is to be able to enable it for the analytics and advanced analytics. Data management of how do you bring the data and manage it effectively, both at the edge level as well as at the cloud level and manage it. Integration, how do I integrate the different protocols and how do I make the IoT edge seamless? We will go a little bit details on this because this will be an interesting area that you will also see opportunities for research. The device management, secure device management, because you are connecting some unknown device to the cloud that you operate. That device can pretty much ruin your software on the cloud. So you need to really manage the devices that you connected. in an industrial environment using very robust industrial IoT or IoT device management. And as I mentioned, it's not about just getting the data. We need to create set of applications for people to use the industry veterans, industry users to use it for how they can improve their operations, their assets, performance, and so on. We need to provide set of software tools that will help on building quickly the IoT enabled applications. Security is super important because anything on the industrial security lapses could be a human life damage. Right? The big research area is the edge AI. What this means is that you want to bring artificial intelligence in even a very small embedded edge devices. You want to make highly optimized algorithms that can be run on the edge that will do the prediction and optimization. And last but not least is a digital twin, which is, I would say, that ultimatum of the industrial IoT, that you are physically representing, physical representation, you are making it digital. And you are able to simulate, you are able to say that what if analysis, and you look at optimizing the different parameters, and you will pretty much replicate a transformer from here in the remote center that what should be changed. You will be able to identify that whether the oil levels are going down, not even going and looking at it. You don't need to even put many sensors, but you're able to see it from the soft sensors here. That's a digital twin. So these are all the key areas that one can look at going into details, as well as contributing in terms of both on the hardware or software as well as systems in the area of the industrial IoT. So let me just take a pause here. Do we continue here, or we want to take some questions and go continue? So what would be the format, Sanjori?
Dear participants, if you have any queries so far, you can discuss with sir. Any queries?
Okay, let me
Any
keep
queries?
continuing. Let me keep
Yes,
continuing.
sir, we can continue, sir. At the
Yeah,
end of the
sure.
session, we can have query sessions, sir.
Sure.
Thank you, sir.
Sure. So to summarize things that you have seen, what makes an IoT to an industrial IoT? Number one is the security and privacy, right? Because we are now talking about industrial data. It needs to be secure, it needs to be managed on the edge and cloud. We need to also have a common information model. What that means is that we have to be able to highly effectively manage the sensor data along with the existing system data. You form a data model, a master data for industrial master data we call the common information model. And as I mentioned, we will, ABB as an example is managing the cloud for multiple customers. You are not creating one data center for each of the customers, each of the organizations. We have one set of instances of the cloud in which we bring the data. So you need to keep ensuring that the data is completely secure for that specific industry or customer. It's not possibly compromised to others. You are able to bring the specific efficiency and SLA for a customer, and you should be also able to charge back to the customer that you need to pay this much because you are using this much of my IoT enabled application services. That's called as multi-tenancy. I spoke about the edge computing. And it's also that we enable the industrial consumers to also build their own applications. It's not about we provide, Microsoft 365, you take it and use it, right? It's not. We should provide a platform, industrial IoT platform, in which customers using the APIs provided by us, they should be able to build their own applications. Most important thing is also the scalability. I talked about the amount of data that we collected, amount of AI models that need to run in parallel. So as we speak, for a large hydro power plant in Italy, there are close to about 12,000 AI deep learning models are running in parallel. So you can imagine the kind of the IIoT infrastructure needed for that. both from the IT side, but also that amount of sensorization and data is coming from there to do it. And if we are we from the computer science side and software side, we need to build the softwares that can have the best of the scalability design and architecture in place for that, right? So, so looking at it together, that we see major three areas. One is that how do I get the data? How do I model and the data, and how do I use the AI for bringing the value for specific areas that matters for the industries. I'll take just 2-3 examples for you to see that how this works. So people typically want to see that for getting a complete 360-degree view of critical assets in a plant. That's what matters, right? In a plant, in a commercial B2C, people are important. The social IoT, the people are the ones that actors. Whereas in the case of the industries, the major equipments, heat exchanger as an example, that's exactly what does the whole thermal energy conversion, right? So that's actually very important to look at it on how do I identify among thousands of equipments in my large plant. How do I, when I come to today in the morning, how do I identify which is my worst performing equipments? You can't be going and analyzing. It can't be calling 10 people to go. You cannot go and do the inspection. The IoT does the trick. You have the data enabled from the sensors that identify the key health parameters of this particular equipment. They're all brought through the system I mentioned of bringing the data together. And it brings also the alerts, it brings the different performance measures. It will tell much in advance that there is potential challenges here. You need to go and do the choking. It's not always replacing. It's not about the fault. It's also about doing proper maintenance of keeping the assets to increase the life. That's one of the top use cases for the industrial IoT. Here, people also use it even to change the predictive maintenance strategy using that. The second thing is that it's not about only the keeping the life of the assets or the equipments better. Typically, the assets are connected for doing a specific process, right? And if a specific asset is degraded in terms of its performance, that's going to even impact the quality of the product, that is goods that are produced. So you look at the system as a whole and ensure that the anomalies are predicted using the IoT and the data. And then you will keep always the uptime, thereby the process efficiency as well. And most important aspect in the industry is that get the best of your process and equipments. That's a way to improve the profitability. One of the major use case of the IoT is as well is looking at opportunity loss. What is the desired outcome of your operating parameters efficiency and how much it is operating, the yield that you can improve. So putting it together, you have the data in the industrial IoT landscape of the operations and engineering and IT together. You use the software data model, industry data model standards for industry analytics, apply the AI in the context of the domain, and provide insights and applications, predictions for different kind of users in the industry. It could be a CXO who is looking at how do I improve my profitability of my whole plant, or it could be a maintenance engineer who would like to use the virtual reality and augmented reality for looking at the predicted parameter failure and go and replace it by giving the instructions remotely. Or it could be someone who is wanting to improve the process efficiency by using the IoT data with AI. So that's something that to see that the value. But this is again, you will see a pretty complex, but my idea here is to also make you to start thinking about how typically the IoT applies on the industry, right? What you see here are the different layers of the industry the firewalls are put across. The first one is that where the actual process happens, the equipments and the control systems. The second one, which I talked about, the technology network, the edge where the data is collected, and through the different protocols that is pushing the data to the either the customer's corporate center, data center, or the cloud. So when you are designing the IoT software applications for industries, you will always keep in mind that it needs to operate in a modularized fashion in each one of these places. For instance, Genix as an industrial IoT and analytics from ABB that can operate with a different kind of the capabilities here in the cloud, or it can operate in the customer cloud, or it can operate just next to your sensors, right? As an edge application. So you look at how do you address the different industry deployment needs when you talk about designing the industrial IoT. So that's just getting a feel of how it is being deployed as well. Let me just jump on one aspect which I wanted to cover, which will be possibly something that you can quickly relate it to things that you are studying. Just jump on. When we start deploying IoT from the sensors and what technologies are being used to connect, that is an interesting area to look at, device integrations, right? So we look at we just to take the simpler ones here. The first thing that we look at is that how do we connect the different devices to an edge? So these are the different protocols you possibly would have studied. OPC is a very common standard, Open Process Consortium. It is actually the one which is widely used for how do you connect different devices, IoT devices to an edge. In this case, it's called as a Genix Edge from ABB. So you have the different protocols. You might have studied about HART for the safety protocol, IEC 61850, which is for the electrical equipments. First thing is you get all this individual equipments connected to an edge. Edge is nothing but a hardware computer, purpose-built computer, in which the software which brings the data, connects the data, and pushes securely to the cloud. That's what the edge device does it. And you can choose your area of expertise just in this area, in this specific domain itself, that how do I make all this different kind of the industrial equipments, the wireless connectivity, direct connectivity, or the field bus connectivity, or using the OPC EA standards that are supported by some of the intelligent devices. How do I bring all those data, the field data, to an edge? This itself is a pretty complex area to work on. So if you are hardware centric, embedded software centric engineer, you could look at bringing innovations here. That how do I ensure the data is brought securely? How do I look at different kind of data, real time data? What if the sensor is failing? How do I ensure that I pick up the lost good data? How do I know that it's a lost good data? All those things are part of the first layer, which is how do you bring the different device information to what we call as the edge. The edge is a smart computer running in the plant that collects all the data, then decides what data should be going to the cloud for further analysis. As an example, this is like an industrial computer, wherein the ABB's Genix Edge is provided as a software, or it could even run on a VMware virtual machine as well, right? You provide that to collect the data. And you will study a lot of things here in terms of the TPM, because you need to, from the chip level, the chip which is actually booting this industrial computer, even that chip level will be certified and managed from the cloud, because we will first check when somebody is trying to connect like this, let's say from a plant in ExxonMobil or Shell, they are trying to connect to the ABB's industrial IoT cloud. First thing we will check is that is this device is valid. How do we identify is that there's a chip which is inside that has a specific code, which is called as, we call a secure boot TPM, that will analyze that it's a valid one which has been certified by ABB that we can connect and get the data. So we don't want somebody to come in between and hack the network and provide different data. So you bring that data securely, and then you will actually go into, yes, I'm able to get the data here, and how do I look at the whole protocol for securely connecting? I'll possibly skip some of this because this might need a little bit more time, which we lost it, and I don't want to rush because then we'll see that everything is complex. The only thing that I would like to then bring it for today before the question is that once you bring the data you securely, you are able to then apply the data using a standard process of how you use the data for AI. A lot of you must be studying data science heavily now. This is an example where we are getting the data from the different sensors in a data center. This is an Amazon data center. You have tons of IoT sensor data just for the cooling system alone. The cooling system is all about a chiller plant finally exerts the heat in the cooling tower. The C rack is all your IT equipment rack. You have sensor data from all this, and this is kind of a flow which is defining it. The tons of tag data we call as the IoT sensor data is brought in. Next thing you look at is the industrial aspect on the IoT that, okay, my goal here is to optimize the energy consumption in the data center. I would like to ensure that the heat absorbed in the data halls, which is the heat really generated by the IT equipments, the servers, big servers, storage devices, networking devices. I want to ensure that that heat is not getting bigger because of the different other systems which are there. In this case, the AC, precision conditioners, AC systems. I don't want to be creating more and more energy losses, which means that we need to spend a lot of electricity for providing the energy. So here we analyze the whole energy flow, which is coming from the sensor data from the different equipments, in this case from the AC and precision cooling systems. Once you have that data, then we use the whole industrial process, data analysis process of how do I look at specific data that makes sense for me? How do I extract the data that will be applicable along with the different systems? A technique which is highly used on the industrial context called as a feature engineering, you would have studied in the data science. How do I use the feature engineering for extracting what specific set of parameters that I need to analyze it and use the machine learning models? So that's kind of what we call doing the whole analysis of the data. And ultimately, if I just need to jump on here, I might possibly go a little bit more details in the tomorrow's session on this. As a case study, you will apply the whole the modeling techniques, and ultimately the achievement is here. Yeah, so I'm able to see that I'm optimized. How do I switch on, switch off my different cooling fans and the cooling systems based on the data points and reduce the energy load, thereby making a saving. In this case, the data center is able to, using the IoT and AI, they are able to save close to about 8% of the energy, which is turning into per year something around, for all the data centers, close to about $80 million. So that's kind of an impact on industrial IoT in the context of the different industries using the data that can create a value. So I might want to just run quickly. Let's see if I am able to see, show, maybe I will do that tomorrow in the interest of time. Let's just jump on the question and answers. I will possibly show tomorrow on a use case study, but also how it is deployed by showing a real video of that. You will get to see things in action, then potentially seeing the concepts that we went through today. And if you have any questions that are things that you wanted to look at, that you wanted to address, we did not address today, I'm happy to answer it today as well as tomorrow. So we can open up for questions.
Dear participants, any queries? Participants? You can unmute your mic and discuss with sir. Otherwise, you can post your queries in chat box.
300 microseconds.
Any queries, participants? Sarah is waiting. Sir, I think no queries, sir.
Okay, good. So if any questions you have it, please send it on to the your coordinator. We will certainly cover. And also, if you want to give certain comments that this is possibly you want to make it a little bit more easier for you to, or which ones you are able to relate it, which ones are not able to relate it. If you can give some inputs, we can absolutely fine tune it for tomorrow. And
Sir, one question in chat box, sir.
Yeah.
What standard follow the securities in IIoT?
Okay, great question. So there's something called as a cybersecurity alliance, which we have it, which is covering the different security standards for both OT security as well as IIT security, and there's something called as an OT IT security convergence. There are both tons of the ISO standards, starting from the ISO 27000, as you possibly know, which defines the process. There's also standards for the security operations centers, which is called as SOC standards. Then you also have, which I was just showing, that security standards, which is just at the device level security to connect. They're all IEC standards. Then you have the data security standards, which are multiple of them. The most predominant one is always related to a specific industries. For instance, you saw that I talked about the API 580, which is a standard for the industrial security. All the IT security that is on the cyber security side applied will also be applicable the moment we go to industrial IoT, because you are connecting the OT system to IT systems. Industrial cybersecurity by itself, OT systems, which is called as the automation systems, which are your sensors connected to your physical equipments and processes. They all follow the IEC 61850 standard, which is a primary standard, but there are specific IoT security standards for each of the different protocols that are in each layer, from the device to the edge, from edge to the edge to your data center, or edge to your cloud to the MQTT. And of course, when you're going to the internet, we all know that it needs to satisfy the certification management to the secure HTTPS, which is fundamentally a standard where you connect your IoT to the internet or the cloud. Right? And there is a lot detailed cybersecurity procedures that are called as standards. I'll be happy to point you the link. If your focus is on the cybersecurity for industries, you can certainly go and look at the areas where a lot of research is happening, and where there are already set of software packages available, such as the OT SIEM, which is called as security incident and event management, which is based on the different cybersecurity standards. You can look at researching on those areas as well as learning more there. Yeah. Any other question?
Thank you, sir. Any other question? Ma'am, somebody.
Sir, good morning. And from your, it's a very good presentation, which gives motivation towards the industrial IoT. And I have one question, sir. Usually the IoT lifetime is very limited. And how far this IoT plays, or edge plays an important role in oil, sir? Because it will be located in seaside. So how this edge will be helpful for oil refineries or oil wells located in the sea, sir? How far the data will be effective, the data transmission and other point of view, sir?
Yeah, good point. In fact, I would have covered some of those which were there. In interest of time, I could not cover. One of the major use cases is the offshore wells, which is the oil platforms. Typically, the oil platforms will have this major rigs and equipments. They are today highly sensorized. or they are connected, engineered through the wires to the small controllers, which we call as the PLCs or the remote controllers. These controllers will sit on the oil platform, which is in the sea. Right? Then they transmit the data through different means. They are transmitting the data through the wireless communication, or they will also transmit the data even through the satellite communication in which we get the data, especially for the oil containers that actually shifting the crude oil as well as the processed oil. So the data is brought from the oil platforms to what they call as the offshore centers, wherein we analyze the data much more, but in the edge, which is sitting directly just in the oil platform itself, we could bring the value of data on AI. That means that we'll run the software in the edge devices, edge computers that are sitting in the in the platforms which are in the sea, right? Things like, it'll look at what is the health of your drilling. Is it using the geoscience as well as the real-time sensors of the drilling machine? It will identify that what is going to be my crude oil quality when I go specific depth further. This kind of information, real-time information, is extremely important when you are looking at the oil processing or oil extraction, exploration we call. Other use cases super important is that these big platforms that you have it, the rigs and platforms of the oil platforms, you need to manage the supply chain of moving them in an effective fashion. That means that you need to connect this data to your actual refinery, which is getting this crude oil and processing. You might want to be seeing that if I need to manage the logistics of my rig and platforms effectively, I need to connect the data from what is happening on the production on the refinery versus how the oil is getting extracted from the platforms in the sea, or we call a subsea. So the industrial IoT plays significant role today in terms of upstream oil and gas, wherein how do I ensure this critical equipments are always managed with the high level of analytics for predictive maintenance? How do I keep monitoring the conditions of this equipments remotely? Because you can't have a large software systems sitting on the platforms. The edge platforms plays a significant role of ensuring that the right data is being securely pushed to the cloud. Of course, you don't have a high connectivity of internet when you go into the deep sea, but you use the wireless communication network available first to get to the offshore centers of the oil and gas centers. From there, you obviously have the internet connectivity on the secure internet, or you have your for instance, if you look at in the IOCL today or the ONGC in India, they have put their own specific line, big, huge MPLS line across their oil wells and extracting units across India, right? They are connected underground cables that are bringing the data to the main station, which is in Delhi, wherein you will see hundreds of monitors, big, huge monitors, wherein the data is brought and digitally visualized and managed. So clearly, it's a big value for IoT and edge computing for the oil and gas industries. Same as for the marine industries, where the data is always coming from the satellite, from the vessels, then processed centrally in the cloud. Did I answer your question?
Thank you, sir.
Dear participants, any queries? Sir, I have one question, sir. If
Sure,
as a researcher, if I select my domain as industrial artificial intelligence, whether this IIoT is mandatory, sir, or they are correlated?
Yeah, it's basically, they are absolutely correlated, but how much depth you want to go is depending upon what you are trying to solve. If you are solving in industrial AI, if your focus is to use industrial AI to solve certain use cases on data itself, you want to look at how do I contextualize the data much more meaningfully from the AI, then you need to also understand the IoT. On the other hand, if you're going to use the industrial AI for solving specific, like an energy efficiency, I spoke about it, how do you optimize it? Then you don't need to worry about how the data is coming. The data engineer, the IoT engineer will ensure to bring the data. And you need to look at, once the data is contextualized, how do I use the pattern of the data and how do I use a different algorithm, choose the right algorithms, and do the predictive analytics using AI. That's where your focus is. So if your focus is on the industrial AI, you might need to know about roughly 30% of industrial IoT, but you focus more on the AI and data science. That will be your 70%. On the other hand, as I was saying, if your focus is on the industrial IoT security or industrial IoT device management or industrial IoT data integration, or how do you make smart systems for bringing whole amount of data, then you need to focus a lot on the industrial IoT. That's where you possibly will put your focus accordingly.
Thank you, sir. Participants, any other queries? Participants? Sir, I think no more queries, sir. Can we conclude this?
I want to apologize for the inconvenience for the first half an hour as well. So which possibly made me also to go a little bit faster to cover few areas.
So it's due to some technical issues, sir. So
yeah, it looks like you don't allow the external computers. You are secure enough that NIT is not allowing unless I use your account.
Yes, sir. Though I on everyone, but it's not allowing that ABB account, I think, sir. And that was insisted by Narendran, sir.
Correct. So thanks a lot for your time. If you students, if you think that's for any specific areas we could not cover or touch, you can inform, and I will try to also quickly cover it tomorrow. And
Sure.
if you have any suggestions for tomorrow's session, that what you want to cover as well, you can inform the coordinator, and I will accordingly adjust my session tomorrow. Thanks a lot.
Sure, sir. So we can conclude the session now. Time is precious. Make sure you spend it with the right people. I'm very much pleased to state the time spent with Mr. Rajesh. It was very flawless and the presentation went very good. Hopefully, sir came by 9 a.m. very sharp due to some technical issue. It happens. Hopefully, by tomorrow, we'll have some more time with sir. As a personal note, I was eagerly waiting to attend sir's presentation by seeing all his profile. We are very much thankful, sir. We know how busy you are. You volunteer your time to share your bunch of industrial knowledge with us. On behalf of CSE Department, NIT Puducherry, I extend my warm greetings and thanks to Mr. Rajesh, sir, for his bunch of industrial knowledge and the flawless presentation. Thank you, sir.
Thanks, everyone. Thank you. Thanks for the opportunity.
Thanks. Participants will have a short break. The next session will be started by 11:30. We'll meet after a break.